Okay, so today let's go and look at Lab 6. And Lab 6 covers arrays and vectors. Vectors are like arrays. So I went ahead and made a folder for Lab 6, and I created a source code file, ex1.cpp. Oh, and I forgot. I better do this first, just to make sure. Oh, you know, the network that the repository server is on is very slow right now. And I asked the system administrators to look into that problem. It does connect, but it takes a long time. So I'm just going to let that run. Just see how that goes. But I created a file, ex1.cpp, still running. And then this is in the file, so all tests pass. So we're going to do test first. We're going to use a test first approach. So the first test will succeed. And I didn't run it. I need to run it. All test pass. There we go. So we don't know what we're testing yet, but when I glanced at this, I noticed write test code that thoroughly tests a function. The test code should use assertion, so just getting ready for that without kind of looking at anything else at this point. All right, so exercise 1 is about finding the maximum value in something called an array, and this is the syntax right here for declaring something as an array. So an array is a sequence of data, items of data. It's a sequence of items of data in computer memory, and a contiguous sequence. So the data is next to each other in memory. So if there's one piece of memory at memory address, n, then there's the next the next valid address after that. To hold data would have the next item in the array, and so on. So this, when you have data in computer memory, you need to, when you write code, you need to have a name that represents that data. So here, the name is A. So A is the name of this sequence of data. The data has to have a type when you're working with arrays. Arrays are typed. They contain typed data. So if you can have an array of int, that's what we have here. You can have an array of double. You can't have an array that mixes int and double together. Not in this language. In other languages, you can. So an array is like a container. It's a container that has its elements, its items, organized as a sequence. And this little bit of syntax right here is what says that A is an array. This says that the letter A represents a sequence of data in memory. And the data that's in the sequence, all of the data are ints. Now, when you see this notation here, the thing to note about it is there's no information about the size of the array. It's not built in to what's stored in memory. So we need to keep track of the size of the array, or the number of elements in the array. We have to keep track of that separately from the array data itself. And so that's the purpose of the second argument in this function. Now, we don't have that problem when we work with vectors. Here's an example of a vector v, which is similar to an array, the array A. Both the vector v here and the array A that we looked at both represent sequences of integers. But the vector v is an instance of a user-defined data type, even though we didn't define it. We still call it a user-defined data type, or a complex data type. And And it contains in it the number of elements in the vector. So we can pull the number of elements out of the vector by using a vector function. But arrays don't have functions. They're primitive data types. They're not objects. We don't use the dot notation with an array. So we don't go a dot size to get the number of elements in A. But for V, we would do V dot size. That would give us the number of elements in V, because V, and historically, this notation here and what this array represents is a part of the C language. And the vector came later as part of the C++ language. So C++ is the evolved form of the C language. So the C++ language contains within it, as a subset, the C language. And so vectors are, in many ways, more convenient than arrays. But still, you need to work with arrays in many cases for certain reasons I'm not going to get into right now. So this function here, called myMaximum, I didn't want to call it maximum because maximum is a function. It's a typical name, and I've had naming problems, a naming conflict using the name maximum in previous classes. So I know not to call it maximum anymore. So I call it myMaximum. That doesn't conflict with any pre-existing maximum function as part of a header file that I include in the program that I'm going to write. So we need to define this function myMaximum that takes an array, A, and the number of elements in the array and returns the largest value in the array. So we'll need a loop. We don't know how many elements are in the array. So that's a variable that's passed in. So we'll need a loop that looks at every slot in A and determines which is the biggest item, and then return that. Now let's take a look. So here I'm defining the function. And I'm going to change my notation, my style a little bit. This is a different style. I put the braces on the top like that, so it makes the code a little bit more compressed. This is the more common style, by the way. And so what we want to do is call this function. And when we call myMaximum, we'll pass in some array. And we'll call it, say, A1, because I'll call myMaximum with a number of different arrays. And we need to indicate how many elements are in the array. I'll say 5. And this myMaximum, it returns an int, right, which is the largest value. So we could store that value here, like that. And then we can call assert. And let's suppose that the largest number is 19. So we'll assert that the max is 19. We'll need to use the assert library. So the assert function, not library. So let's stub this out, and let's just return a 0. It's a typical value to return in a stub. So this assertion should fail. Now this won't compile. Let's see that it doesn't compile. Oh, look at this. Git pull did not work. I'm going to try again. Cannot reach the network with the repository right now. What's the problem?
AIs, or any A1s.
You know, we didn't declare A1. We didn't define our test data. So how do we create an array? So one way to do it is like this. This is the, let me do it two ways. I'll do the slow way first. And I'll change the size to 3. So we want an array A1 of size 3. So that creates it right there, I think. And yeah, that should do it right there. Let's try that. That works. Fail. So the array, when you define an array like this, you're telling the compiler to allocate memory. In this case, it's something called a stack. And to allocate memory to hold 3 integers. But the compiler does not generate code to initialize that memory. So we need to initialize it manually. Other languages generally will initialize something like this to zeros. All right, let's put a 0 in here. And this is how there's 3 slots in A1. Slot 0, slot 1, and slot 2, or 3 positions. Position 0, position 1, position 2. So remember counting, labeling of positions in an array starts at 0. And we initialize everything to 19. Well, let's not do it like that. Let's put a 1 there and say a -3 here. Still, the stub is always returning 0, so we'll always fail. So now we've allocated memory to hold 3 integers and initialize that memory. Now let's go ahead and implement this this my maximum function. So what we do here is we have to look at every item. And we can only look at one item at a time. So we'll start by declaring a maximum. I'll call it n. We'll set a maximum to, say, the first item in memory. And then we'll look at the other items in memory, starting at 1. And we need to put in, we have the number of elements we need to stop there. And let's increment I. And we'll keep looking at m. We'll do it like this. So what we'll do is we'll start by looking at A0. And we say, well, we haven't seen anything else yet. So what's in slot 0, what's in position 0 is our current maximum m. So let's take it out. Let's make a record of that. Now let's look at all the other positions and see if we find a number that exceeds our record of our current maximum value that we've seen so far. So if A of I is bigger than m, then we found a bigger value. So what do we do?
Return.
Huh?
Return false.
No, not return. We got to return the biggest value. We're in a loop. We're going to return m. So remember, m is a variable that's going to keep track of the biggest number we've seen so far. Now, just imagine if we're going through this data right here. The first line sets m to what value? 1. All right, m is set to 1. Now we enter the loop, and I starts at 1. And we say, well, a of 1, is a of 1 bigger than m? Is a of 1 bigger than 1? M is 1 right now. So I'm from down here. M came from there. So what's a of 1? 19. So is 19 bigger than 1? Yeah, it is. So that means we want to change what m is. So a of 1 is now holds the maximum value we've seen up to this point. And look, the next time it goes through the loop, now m equals 16, or 19 rather. M is now 19. And then when we, at the bottom of the loop, we'll increment I, so I becomes 2. And then we compare a of 2 with m. A of 2 is minus 3, and m is 19. So this inequality is false. So we leave m at 19, and we exit the loop and return 19. So you need to understand this algorithm on your own. You should come up with this on your own without looking at your notes. Will this test pass? Will this test pass? Anybody ready to bet money on this one?
Yeah, I think.
Yeah, okay. It's still, we cannot connect to the repository, so there's a problem there. All tests pass, that's great. Got it. Let's do another test. This time I want to show a different way to initialize an array that's a little bit more compact. Here's an alternative syntax for defining an array, all in one line. Well, I used all negative numbers, huh? All right, that's just to see if I can confuse the code. Oops. And I'm just going to bring these. This is like test 1, right? This is, I could think of it like that. It's test 1. This is test 2. All right, so A2 has 4 elements in it. And the max is, what's the max? What's that?
3.
Minus 3. Okay. Let's see if that runs. Oh, what's the problem? I'll let you debug it, not me.
Because you need like max 2.
What's that?
Because they're both the same integer right now.
Yeah.
It has to be like max 2, right?
Yeah, see here we're saying, let there be a max. Down here we're saying, let there be a max. So wait a minute, I can only handle one max. So we can just take that out. Now we're not here. We're no longer saying let there be a max. We're saying set max to something. Someone already let it happen. Okay. But you know, because we're talking about saving space and making the code more readable, why don't we just go ahead and do this? How's that? How does that look? Is that easier to read or harder to read? That's up to you, right? For me, this is easier to read because I read this all the time, my whole life. Well, most of it anyway. But for you, maybe this is harder to read, so you would write it the other way. It's up to you. Let's see if that works. Alt has pass. I'm wondering, there's another way to make the code even more compact. Let me try this just to see if this works. Can I just do this? I don't think I can do this. I don't think this works. You know, in another language, this probably would work, but I don't know about this. No, that's not going to work. That will not work. I would bet against this one. Look, I notice an inconsistency. I've got to put a space in there. It really helps your readability if you follow some consistent pattern when you decide on spacing. This will fail. This is no good. Anyway, this is enough for now. Any questions about this? Okay.
That's fine.
Let's do the next problem, and I'm just going to assume it fits into that form. Appending integers. So here we have a function. We're going to implement and test this function down here. Write test code that thoroughly tests the function. The test code should use assertions. It's the same pattern. Let's go ahead and get that done. This time, I'm going to show you an issue here that I always forget to do when I teach this class. But today, I am not going to forget. Let's define the function after we define main. All right, there's our code. Let's see if that compiles. This will not compile. I believe this will not compile. Does anybody know why I believe that? I don't want you to answer that question. I want you to answer the following question. What's the problem? Why is that not compiling?
No, if it's declared.
What's that?
No, declared. None of the new line you just put in is not declared.
Wait a minute, I can't even read that. If I can't read it, how are you going to read it? There we go. That's the problem. What should I do? You know, I got to tell you something. This is typical. You're staring at this. I mean, this is hard to understand, right? I mean, it's just you got it. It's like another. It's another language, and probably a language you're never going to learn. And I don't know. It's like being a detective. You have very incomplete knowledge, and you're staring at some clues, and you must be creative. You know, the concepts that you understand, the limited knowledge that you do have, try to apply it to the problem and use creative thinking and understand it and, you know, come up with at least a hypothesis of what's going on and then test that. And this is so typical, you know, I mean, you never get to the point where you're going to read like every comma and quote and symbol on there and understand in all completeness. I mean, you know, if you were a compiler writer and you were working on this specific compiler, you would probably understand this output very well. How many people in the world are at that level? Very few. But how many people are writing code, writing C++ code? I mean, many, many. But there's something like, there's somewhere between 1 and 2 million programmers in the world. And how many of those have to deal with C++? I don't know. That's a good question. 500,000? Something like that. Anyway, what's the problem? Any detectives in the audience today?
Well, I was guessing that none of it was declared.
Huh?
None of it was declared.
What? It's not declared?
None of it was.
What variable?
Void, vector, v, and
Yeah. Variable has incomplete type void. What does that mean? How about this one? Use of undeclared identifier vector. So it's saying vector is undefined. It's just a header file missing there. Okay. That's all right. Okay, so let's go ahead and now remember vector is similar to an array. It's a sequence of items in memory. But it's a more sophisticated sequence. It looks like an object, like that's created out of someone's class. Actually, if you look in the library, you can read the source code. This class is called a template class, actually, and this is the template parameter. So the vector must contain only one type of data. It could be an int, it can be a double, it can be a string, it can be a person object. It's all kinds of things. So the container can contain anything, but it can only contain one type, whatever it is, and you have to declare that type here using the syntax. So use these angle brackets to tell this template class. So it's a template class. It's a class actually that it represents a vector of integer, a vector of double, a vector of string, a vector of person. It's a template for a class, and a class is a template for an object. So it's a pattern of an object. So it's even one level more abstract. And we're not going to get into template programming though, but I thought I would mention it to you. Understand that. But this syntax, which I'm not going to say it first appeared in C++, but maybe it did. But it's very common now. It's just all the new languages. C# has it, Java has it. I'm looking at a language called Dart. Dart has it. And it's a very common syntax and notation. So you start to see this in other programming contexts. And it all means the same thing. So we have a sequence of integers. And we have to understand what that is, but we'll talk about that later. And let's go ahead and call this thing. So we're going to call append, and we're going to pass in some sample vector, say v1, and we want to append like 3, right? Actually, I don't even know what that does. The second number is the number of consecutive integers to append to the vector starting from 0 and ending at n-1. Yeah, this problem is it's not great, but I think it's okay. So let's do this. So we create a vector. Let's do this. We're creating a vector of int, and we'll call it v1. And then we're going to add some data. And you know what? Let's use the same data that we used for the other problem. (119) and -3. Actually, it doesn't. We're not implementing the same problem, so it doesn't really matter. So this results in sort of like an allocation of memory, which is very similar to the allocation of memory that occurs for that array of 3 integers that we did in our first exercise. But it's a little bit different because it's an instance of the vector class, and there's some extra information that's being maintained internally that we don't see. So we have this vector v, and at this point in time, sorry, v1. v1 looks like this. It looks like 1, 19, and -3. That's what the vector looks like at this time. And then when we append this, v1 changes to look like the following. Does it include 3 or not? That's it right there, isn't it? Let me change that. I'm going to make this append v1, comma 4. So it starts at 0 and it goes to 3. So it stops at, it goes from 0 to n-1. So the n is being passed in as the second argument. This is n. And we're going to append the values 0, 1, 2 through and including n-1. That's what we get. So we can put some assertions in there. I think I'm going to go back to 3 because it's too much to test. I'm just trying to do this. Let's have some assertions. So v1 of 0 is 1. And v1 of 1 is 19. v1 of 2 is -3. And these should not change after we do the append operation. But there should be a 3, something in position 3, it should be a 0. And and that's 1 and that's 2. So this is in position 4 and position 5. Oops, sorry. So there's the test code. Oops. If you just ignore the test code right now, except for this one line, there's going to be a compilation error. And notice that here I'm calling the function append. But the function append is defined down here. But the compiler is processing the file in a single pass. And when it gets to this point, it's going to say append. I don't know any append. You see that? If we start at the top and we process, if the compiler processes the symbols sequentially starting from the top, when it arrives at this point, it won't know what append is because we've delayed its definition till the bottom. Okay, let's verify that that's the case. and it's hard to read. It scrolls off the screen. So I'm going to do this. I'm going to dump this into a file named T for temporary. But that doesn't work because this is being written to standard output stream, not the, I'm sorry, it's being written to the standard error stream, not to the standard output stream. So I'm going to redirect the standard error stream to the file T. Now I can look inside T, and I want, see, I did this because I want to look at the first error. I don't want to look at a subsequent error because the subsequent errors may be meaningless. The reports about those errors may be meaningless. It's the first error that sort of has this cascading effect and causes lots of other errors. So we want to start with the first error. Invalid operands to binary expression, void and int. Oh, this is worse than I thought. This is completely wrong. The syntax, I'm not even at the issue of that I'm talking about. This is how it needs to look, right? I had the, unfortunately, I did a big copy operation already. And now we got to kill this. Oh, that wasn't too bad. Does that look better? Maybe it's hard to read like this. I could clean it up a little bit. Maybe it'll look a little easier to read. I don't know if that's easier or not. It makes a difference when you're clean and organized. It's a lot easier to write a program and to debug it. All right. Here we go. Use of undeclared identifier append. So it's this line 16. It says line 16, use of undeclared identifier append. I'm going to jump to line 16. There it is right there. It's saying, I don't know what append is. Now, let's suppose we, just for organizational reasons, we want to keep the function defined on the bottom. So what we need is what's called a forward declaration. And I'll put that right here. And this just tells the compilers, notice I put the semicolon there without curly braces. So I'm not implementing the function. I'm just stating that the function exists. I'm saying to the compiler, append is a function. It's a void function, it returns nothing. It takes a reference to a vector of int as a first argument, and it takes an int as a second argument, and that's all I'm going to tell you right now. I'll tell you the rest later. So that when the compiler gets to this point, it says, oh, append. That's the thing you're going to tell me the details about later. So I'll accept that at some point in the future, you'll provide an implementation. I'll make a note to link to call into that implementation later on. And here's the delayed implementation. You know, I have the curly brace. It does nothing, but you know, that's, we'll have to fix that. But it is an implementation. It has the curly braces, which means it gives a collection of commands that need to run when the function is called. So let's see if we fix that compiler error. And we did. But now we still have a stub. This is not implemented yet. So let's verify that our test code runs and reports that there's an assertion failure. This one right here. V1 of 5 equal to 2. This is interesting. But it didn't fail in this one. Is that interesting? That means there was a 1 in memory. because these are invalid indices. 3, 4, and 5 are invalid indices. It just happens that at index 3, because we are indexing outside the memory that the vector is allocated. This only happens in C++, by the way, and C. This will not happen in Java or C# or most of the other common languages because they do what's called range checking. But in C++, for the sake of speed, the compiler does not generate code that checks to see if an index is valid or not. We're passing in an invalid index. 3. Because we create this vector, it only has 3 items in it. Now, we don't know exactly what's in memory, but apparently there's a 0 followed by a 1, but not a 2. Now watch this. Let's replace that with a 4. Let's see if it fails there now. It fails there. For some reason, there's a 0 in there. It may be dependent on when you run it. So actually, we're getting v1 of 3 is the value at v1 of 3 is unpredictable. And so it may or may not throw an assertion. So it's still the way it is. For some reason, there's a 1 gets put here for some reason in memory, and but there is no 2 here. Let's see. Oh, I wonder if we put a 0 in there. Let's see if that works. No, it's not a 0. Maybe it's a 1. No, I don't know what it is. We could print it out. Let's do that. Let's take a look at what's in there. $19? How did 19 get in there? Test code runs. I don't know. Anyway, that's not right. So this should be a 2. I don't know how 19 got it. Obviously got there from here somehow. I don't get it. But anyway. Could be left over from the other code we were running too. You know, I don't know what's in that memory. It's unpredictable. Let's implement the function. So we need to append, this is what we have. We have a vector with 3 items, and then we need to append 0 through n-1, where n is the second argument being passed into the function. So let's use a for loop. And let's go ahead and do this. v1 dot append. What are we going to append? Good. Wondering if people are actually following this or not. I think that's going to work. We just append 0 through n-1. v1 is undeclared. What's going on? Everybody should understand this. This is a very common mistake, right? Have you all made this mistake? We declared V1 here. And here it's telling us V1 is undefined. In one sentence, what's the problem?
Same name.
Huh?
The same name.
Yeah, it's the same name, but you know, why does the compiler say V1 is undefined? This second one, this one. It's not saying this V1 is undefined. It's not saying that symbol is undefined. It's not saying that symbol is undefined. It's saying this symbol is undefined. Let me check to make sure I say undefined. It's undeclared. I'm sorry, undeclared. I say it's undeclared. Why is it saying that V1 is undeclared? Yeah.
Because we voided.
Huh?
Because we had void append.
Void? No, not because we voided it. No. There's a word that you need to learn, and you have to add it to your vocabulary. What's that word? Starts with an S. Nobody's reading the book, right? Scope. Scope. You know, your mother tells you, go clean your room. You go, okay, I'll go clean my room. And then when you're done, she says, go clean your sister's room. You say, whoa, that's not my scope. It's out of my scope. I don't go there. So V1 is not in scope here. This V1 that's declared here, its scope is restricted to the inside of the curly braces where it's defined. So all of these lines we can refer to V1. But we cannot refer to V1 anywhere else because its scope is limited to the main function. Actually, it's limited to the point where it was declared. If I put V1 down here, the first line would be a problem. Because the compiler's going to, remember, it does things sequentially. It's going to get to V1 here. So sorry, the scope is it doesn't fill in the entire function where it's defined. That, by the way, that happens in JavaScript. Okay, JavaScript does something called variable hoisting. So you declare a variable anywhere inside of a function, and it is declared. It is then visible through the entire function, even at points before where it was declared, because those declarations are modified internally. But see, most languages don't do that. All right, so the problem is, so what does this need to be? Not V1. V1's not going to work. What should it be? It's obvious, right? No? Is it obvious? See, we're trying to test this vector v here. Remember, this function is hidden away. It's like, you know, it's a barrier. This is sort of secret unto itself. This is your house here, and this is your neighbor's house, and you know, it's a letter is delivered from your house to your neighbor's house, and well, the analogy can only go so far there, but this when we send the letter, we call it the letter here. But the neighbor, when they receive the letter, well, they don't speak English. They speak Chinese, so they use a Chinese word for letter, Spanish word for letter, and I don't know what that is. So it's got another name. It's the same object, but it's another name, right? And this name and that name is understandable in a different scope. Those are good analogies. Houses, right? People in this house speak Chinese, and they know what V is. They don't know what V1 is, even though it points to the same thing. It names the same letter, the same object. They just have different names for it. So we want to operate on V. Oh, what happened? That's tough. Let's clear the screen. Who can get this? Oh, there's nothing called append. What am I doing? It's called pushback. The append operation, and we used it here. See, this is pushback, but that's, I should have been called append, but they called it pushback. You add to the end of the vector. Sorry, I didn't even mention that. But a vector has a variable size. So initially it's, when you create it here, it has size 0. There's nothing inside of it. When we push back a 1, it now has size 1. When we push back 19, it now has size 3, and so on. So, but it's pushback means add to the end of the vector. Now that works. I'll test pass. And finally, what is this? This is the last lesson of today, and then we're going to quit. Okay. The last thing you got to learn. What is that ampersand all about? It means reference. It means V is, they use the word reference. It's a reference variable. So V is a reference to a vector. And let's just take it out and see what happens. What's going to happen?
The third assertion will fail, or like V5, I think.
Which one?
I think the assert V15 will fail.
Yeah, we'll get back to this original thing. Exactly. That's right. I mean, any one of these could fail. Anyone could fail. I'm going to throw another assertion in there. Does everybody, how many people understand that this is going to make the code fail? Do you know why? You know why. You know why. A couple of people know. Let's watch it fail. Let's see that what's going on? Did I say append again? Append. Oh, I got to do it up here. See, they have to match this forward declaration. They have to be identical. So it won't compile. So I'm not after a compilation error. I'm after the runtime error. Well, this time it's V4. Okay. See, the memory is unstable. Let's make a more stable test. Watch this. The vector class has a size function. It gives the number of elements. Here, the size should be 3. At this point, the size should be 6. Does that make sense? Yeah.
The two asserts you just created, they're missing S.
Oh, thank you. Thank you very much. Thank you. So, look, we create V. V has got size of 0. Just to understand that. This is the kind of test you need to do on your own, well, I think. This is the kind of test, now, let me make that more accurate. This is the kind of test I have to do to understand code that I'm working with and learning new languages, learning new APIs. I have to do tests. So here, when we create this vector v1, it has an initial size of 0. We call pushback 3 times. The size is now 3. And we assert their values. They have not changed. And here, we call our append function. It should add 3 values, so the new size should be 6. But this is where the function will fail. This is where the code will fail. The program will fail at this point. There it is. So it fails. v1.size does not equal 6 like it should be. Now, why is that?
Is it only equals 3?
Huh?
It only equals 3.
It has to do with that missing ampersand here. Because what's happening right now is that when the function runs, a v is passed into us here. You see that? A vector is passed in here. But the way this function is declared, the compiler generates code that makes a copy of the vector being passed in. So now this v represents a copy of v1. And when we call pushback, we're operating on the copy. And then we return. But the calling code doesn't have the copy. The copy is discarded when the copy goes out of scope. See, this copy, which v represents, is only in scope for the body of this function. Once we return from the function, we leave that scope, that memory is freed up, and nobody else has access to it. The calling code is still operating on the original vector, and the copy was modified. So what we tell the compiler is that, no, we don't want to work on a copy. We want to reach in to the neighbor's house and operate on an object over there. We don't want to make a copy of it into our own home. No copy should be made. So we tell the compiler by saying v is a reference to an existing vector. Please don't make a copy. Let's try that. There it is. Now that's called a reference parameter. It's very important, so you need to know that. All right. Any questions? That's it then. We're done.